Good afternoon, class. We are looking at chapter 8, further applications of trigonometric functions. Here's 8.1, the law of sines. Example 4, using sine law to solve SSA, where A is 35 degrees, angle A, lowercase a, side A is 6, and side B is 8. So we start with the law of sine. And we plug in, of course, we have this. Since we have those, we are going to go with the first two, sine A over A, sine B over B, and sine A is sine of 35 degrees, A is 6, and B is 8. So sine B is missing. Cross product, 6 times sine B equals 8 times sine 35. That means sine B is 8 times sine 35 divided by 6. Using a calculator with a bunch of decimals, we get to the value of sine B, 0.7648. If need be, I can write this and then erase it. Over here, class, okay, just in case. So we put this into a calculator and we say sine inverse of this number is B. And that happened to be, we gotta call it B sub 1, because remember, sine is positive in the first and the second quadrant. B1 is sine inverse of this number, 49.9 degrees, which acts as the reference arc, meaning in the second quadrant, you subtract this from 180, from pi, and you get the angle for the second quadrant. So subtracting 49.9 degrees from 180 results in 130.1 degrees. Let's see if they both work. Obviously, this works. Does this work? And all you have to do, add it to 35. As long as it's less than 180, yes, it works. Which means you can add this to subtract it from 180, you get the third angle. That's the idea behind this, everybody. So in the previous example, we also got two angles, but the sum of this one with the given angle would go beyond 180. Has to be less. Even equal is not acceptable. So let's continue here, finish the job. We have one angle 35 degrees, another one is 49.9. So for this triangle, we call it C sub 1. 180 minus the sum of these two will give us the third angle. So we have 35 degrees here. We have 8 here. And in a case like that, 6 could be here or here, everybody. That's why it results in 2. And so let's put in the vertices. This is A, the given 35 degrees. This is C. And this one, we call it B1. This one, we call it B2. And of course, C has two angles, C sub 1 and C sub 2. So for B sub 1, 180 minus 35 minus 49.9 results in 95.1 degrees. That means this big angle. okay? The entire angle, C, is 95.1 degree. That's the meaning of it. So this is this one. Okay. Now, when we continue with that, that's a different story. It gives you that little one. But for now, ignore that. So now we are going to go with the rest of the sine law to figure out what's going on. So we found this to be 95.1 degrees. So we are going to use that and find the opposite side, AB1, we're going to call it C1. So we use the fact that we have this part. So we will use this instead of sine B over 8, we're going to go with sine C over C. Sine C is a sine of 95.1 degrees. And C, we're going to call it C sub 1 again, because we have two different triangles. That means this side AB1, this. So maybe I write this somewhere. So by C sub of 1 lowercase, we mean AB1 distance, okay? That's the meaning of it. So cross product. You cross product these two, you cross product these two. So C1 is the cross product of 6 and sine 95.1 divided by sine 35. 6 times sine 95.1 divided by sine 35. Putting it into a calculator with a couple of decimals results in 10.42. What does it mean? We have A, B, C. We have all three sides. We have capital A, capital B, 1, capital C1. We are done for one of them. We got all the information we need. Let's move on with the second set, in which case A is 35 degrees, B sub 2 is 130.1 degrees, and C sub 2 would be 180 minus the sum of these two numbers. So C sub 2 is 180 minus A minus B2, which means 180 minus 35 degrees minus 130.1 degrees. Or you can say add these two, subtracted 180. It has the same meaning, 14.9 degrees. This is referring to this angle. Okay, everybody, this one. Okay, so in essence, the angle A, C, B2. This is what it's referring to. Okay, so we can see that from the graph. All right, so we have all sides. We have, I'm sorry, we have all angles. We have two sides. So we need to find the missing A, this one now. Again, we're going to use this one, sine of 35 over 6, because it's known, it's given. And sine of 14.9 over C sub 2, which is AB2. So just for the sake of argument, so let's just write this over here. When we say C sub 2, it means the distance A. B sub 2, this distance. Okay. So This is B, this is A, and now this is the C. We call it C sub 2. Cross product will do the job. That means sine 35 times C2 is 6 times sine 14.9. So 6 times sine 14.9 divided by sine 35 is the answer. Putting it into a calculator, using a couple of decimals, we end up with 2.69. So this is 2.69, everybody. Let's put all of them together. If you look at this, the big one, okay, this distance is C sub 1, and this one is C sub 2, 2.69. This is C sub 1, 95.1 degrees. The small one is C sub 2, 14.9 degrees. And this is B sub 2, 130.1 degrees. So it's pretty straightforward, everybody. Solve the triangle when A is 2, C is 1, C, and the capital C is 50 degrees. So we go with that and whatever is given. So we can use sine C over C, which is given, and sine A over A because lowercase a is given. So let's go with the first and the third one, putting it together. So sine A over A, sine C over C, and replace this one with 2, sine of 50, and 1. So obviously, sine A times 1, meaning sine A, is 2 times sine 50. Sine A is 2 times sine 50. We use a calculator. We end up with, doesn't matter how large it is, as long as it's larger than 1, then there is no solution. Because sine is between -1 and 1. So no triangle, okay? Because, as I mentioned, this is larger than 1 and sine theta is between negative and positive, and the range is that. So that's why it's not going to do it. So we looked at different cases, a case with a unique solution, a case with 2 solutions, the previous one, and now a case with no solutions. All right, we are going to move on. We want to solve applied problems. Example 6, a surveyor takes 2 sightings of the peak of a mountain at distance 900 meters apart on a direct line to the mountain. So here's the peak of the mountain, and 900 meters apart takes the angle of elevation. The observation are at angle of elevation of 47 and 35 degrees, respectively. If the transit, this equipment that is being used to survey, is 2 meters high, what is the height of the mountain? So we are interested in finding the height of the mountain. We are given 35 degrees here, 47 degrees here, H here, B here, 2 meters here. First and foremost, the height is B plus 2. So when we calculate this part, again, we wanted to make sure we understand this. We put it on a side. So from where the transit can see, so from here it's B. So all we have to do, calculate the B and add it to 2. So as we look at this, everyone, we know it's 180 degrees. 47 plus what number? So C plus 47 is 180. So again, we are looking at this is 180, everybody. So C is 180 minus 47 results in 133 degrees. So if now we have the C at 133 degrees, and this one and this one and A, the small one must add up to 180 degrees, then A would be the sum of these two subtracted from 180. A plus C plus 35 must add up to 180. We are looking at this one, right? And so 180 minus the sum of those two numbers will result in 12 degrees. So pretty straightforward. So what happens when we have those? If we use the sine law for this one, everybody, because all angles are known, all sides will be known because we know one side. So we can use the sine law to find this side, to find this side, we can find them. You can find either one of them, makes no difference. We just need one of them. The reason we need one of them, because sine of 35 is B divided by C, sine of 47 is B divided by, I would say B. We call this, we call this one B. So B divided by this. So let's find C. To find C, we're going to go back to the sine law. The known values, sine of 12 degrees over 900. The missing value, sine of this big guy, 133 degrees over the missing C. So this is 12 degrees, and this is the sine that we are going to use. Sine of 12 over 900 meters is equal to sine of 133 over the side we are interested in, lowercase c. Which means cross product. And by now we know C is the cross product of these two divided by sine of 12. So 900 times sine of 133 degrees over sine of 12 degrees. This is sine, everybody. I thought I put sine of 12 degrees, okay? Sine of 12. Putting it into a calculator and using a couple of decimals, depending on how many decimals they asked you, because they gave you 900 here. That means in your calculation, you can answer it with maybe one decimal, okay, just to give you an idea. So 2 is good. 3,165.86, and the units are meters, so that's the units here. So if you have this, practically you're done, because sine of this, 35 degrees, is the opposite, which is b, over the hypotenuse, which is c. So sine of 35 is b over c, and c has this value. That means b is the product of these two. That means this number times sine of 35 degrees. B is 3,165.86 times sine of 35 degrees. And that gives us 1,815.86 meters. So since they had given us in whole numbers, we can assume this is about 1,816 add to 1,818 meters. That's the approximation for the height of the mountain. So that's how you do application, everybody. Another application problem. Coast Guard Station Z, Zulu. You're looking at this setting. Is located 120 miles due west of Station X, X-ray. So the distance between the two is 120 miles. A ship at sea sends an SOS, save our ship, call. So there's a SOS call that is received by each station. The call to Station Zulu indicates that the location of the ship is 40 degrees east of north. That means north, 40 degrees east. The call to X-ray indicates that the ship is 30 degrees west of north. That means the bearing is north, 30 degrees west. So those are the bearings. How far is each station from the ship? So we want to find A and we want to find B, and we are given this one is 40 degrees, which makes this one 50 because they add up to 90. We are given this one is 30. This is actually not given. We figure it out, okay? That is 60, and the distance is given as 121. So if you look at this triangle, we can use the sine law as long as we have one side and the angle of interest. So we have this side, but what is this angle opposite that? We don't have that. All you have to do, add this to 110 degrees, subtract it from 180. And that results in 70 degrees. So the angle C is 70 degrees. We are in business, we can use the cosine law. That's pretty straightforward. Now that we have that, we are going to write the cosine law, everybody, which means sine 50 over A, sine 60 over B, sine 70 over C, which is known to be 120. So to find the X-ray, that means to find A, use these two. Ignore the middle one. Ignore the middle one for now. Cross product. So 120 times sine 50, A is A times sine 70. So A is 120 times sine 50 divided by sine 70. That's for X-ray, everybody. Use a calculator. Put it into a calculator. Couple of decimals. We end up with 97.82. This has units of miles, 120 miles. So this has the same unit miles. Now to find B, the distance for Zulu, we use these two. Okay. So the product of these two is the same as product of these two. So B is equal to the product of these two divided by sine 70. So 120 sine 60 divided by sine 70. Sine 60 is square root of 3 over 2, but still you need a calculator for the bottom and putting them together. In other words, we know this is a common arc, but that's just the way it works. And so you put it into a calculator. With a couple of decimals, you write 110.59, and again, the same units as here, miles, which means clearly this one is smaller and closer. If a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long will it take to reach the ship? Obviously, you decide which one to go. This is the smaller one, so we're going to go with this one. And you know D equals RT. That means T equals D, the distance, over R. And what is the distance? The distance is A. So class, distance is rate times time. Distance is the average speed times the time. Okay. And so if you divide the total distance by the speed, that gives you the timing. And we know this to be 97.82, and we know the rate is given as 200 miles per hour. It ends up being 0.489 hours. And again, if you want to know how many minutes, you multiply by 60. And that gives you close to 30 minutes, 29.35 minutes. That's how long it's going to take. So again, pretty straightforward, everybody. The highest bridge in the world is the bridge over the Royal Gorge of the Arkansas River in Colorado, sidings to the same point at water level. Directly under the bridge are taken from each side of the 880-foot long bridge, as indicated in the figure. How high is the bridge? So what we want to do, we want to put this on the side with all the details that we have. First and foremost, this is the height. One of the sides we need, that's all. So we're going to call that X. So we put it here so it becomes clear. Let's call this A. Let's call this B. And this distance is what? 880 feet. This angle is given as 69.2. This angle is given as 65.2. This H is missing, and this side is also missing. We called it X. So first, understanding the question. So if we look at this small triangle, okay, and by the way, we call this B, okay? So this ACD, meaning, let me shade it, meaning this one. Okay, this triangle. We have this one as 69.2 degrees. So sine of that is the opposite H over the hypotenuse X, which makes H the product of these two. Well, if we had the value of X, we would be done. So we are going to find the value of X using the sine. So let's go back to the big picture. All we have to do, find this side. According to the sine law, we need sine A over A equals sine B over B equals sine C over C. We have this side as 880 feet, so we need this angle. These two, add them up, subtract it from 180, that gives you angle C. So in the big picture, the triangle ABC, C is 180 minus the sum of those two, meaning, of course, this one, this angle, okay? Or angle A. CB. Precisely, I will know where it is. And so add up those two numbers, subtract it from C, you get 45.3 degrees. Now we can use the sine law. Sine A over A equals sine B over B equals sine C over C. And what we have here, we have the C, the angle is that, and we have the side lowercase c. So we're going to use that. And then we want this one, we're going to use it with this angle. So we are going to say sine of 65.5 degrees over x equals sine of 45.3 degrees. So this is 45.3 degrees. Sine of 45.3 degrees over 880 feet. So I hope everybody's clear on that. We are using the sine law on that. And so the product of x and sine of 45.3 is the same as the product of 880 and sine of 65.5 degrees. So we multiply these two and we divide by sine of 45.3. That becomes x or AC. X or AC. Okay. 880 times sine of 65.5 divided by sine of 45.3. At this point, you have to put it into a calculator. We get 1,126.57. What are the units here? Feet. You use the same unit. Always pay attention to the units and answer them accordingly. We go back to this and we say, okay, we got the x. We got the x. Replace it with this number. Put it into a calculator. The product of these two is the height of interest. How high is the bridge? 1,053.15 feet, according to our calculation. So we are looking at applications, everybody. Example number 9. The navigator of a ship at sea spots two lighthouses. So this one, two of them. That she knows to be 3 miles apart along a straight seashore. So they have a distance of 3 miles. She determines that the angles formed between two lines of sight, so from here to here and from here to here, two line of sight observations of the lighthouses and the line from the ship directly to shore, drop a perpendicular to this line PQ, are 15 and 35 degrees. In essence, they are giving us everything. We should be able to figure it out, by the way, as we read this question. Sometimes it may be difficult, but it is important when you are dealing with questions like this. Everything is about the drawing. This can't be done without the drawing. It's either given to us or we come up with that. So let's, so what do we want? How far is the ship from a P? How far is the ship from Q? So we want the two sides. In essence, you're dealing with this triangle, everybody. okay? One side PQ is known. These two angles are known and nothing else. Now we need to know all sides, only one side is given. And it's really not that big of a deal. We can figure it out. So we want to find PR, if we call this R, for the first part. And we want to find QR for the second part. Okay, so that's what we are looking for. Let's find the angles. It's very easy to do so. If you look at this one, it's a right triangle. So if this is 90 degrees, this is 15 degrees, this must be what? 90 minus 15, 75 degrees. What about this one? This is a 90 degree, this is a 35 degrees, so this must be 90 minus 35, which is 55 degrees. Also, what about R? R is the sum of 15 and 35, 50 degrees. So let me erase mine so you can see that. So 35 plus what number is 90? 55. 15 plus what number is 90? 75. What is this angle R? The sum of these two, 50 degrees. So this angle, this one is, we call it angle R, is 50 degrees. So we have three angles, all angles. We have one side, we can find the missing sides. So law of sine A over A equals sine B over B equals sine C over C. So we are going to use PQ because it's a known side. So sine, and again, we said this is 50. So sine of 50 over 3 is sine of 55 over PR, because that's the first one we want to find. How far is the ship from the lighthouse? P, that's why we want PR, everybody. Okay. And so the product of these two is the same as this one, cross product, right? Therefore, PR is 3 times sine 55 over sine 50. Put that into a calculator. 3.21. This has units of miles, so this must have the same unit miles. Now for this one, again, we want to use the known fact sine 50 over 3, but this time sine of 75 over QR. Sine of 75 over QR. Again, cross product. The product of these two is the same as the product of these two, which makes QR 3 times sine 75 divided by sine 50. Again, you put that into a calculator. Gives you 3.78, and the units that is given for one side in miles. So very straightforward when you do the drawing and you figure out the angles and so forth. How far is the ship from the shore? We want this distance, everybody, which is called D, this distance. Is called distance D. And so we can use one, it doesn't matter which one, the top right triangle or the bottom. Either one will do the job, class. You can use the top one or the bottom one. Makes no difference. So if we use the top one, this is point P, this is point R. This distance, we found it to be 3.21. If we use that one, we use 3.78. Okay, this distance is 3.78 if you use the bottom one. Okay. And so if you want to stick with that, you know, and I wouldn't, but just for the sake of argument, you clearly this is 90 degrees. So sine of 90 over 3.21 is sine of 75 over D. If you want to stick with merely the sine laws, you want to go with that. And the product of these two is the same as this one. Sine of 90 is 1. So D is basically the product of those two. You put that into a calculator and you get 3.10. And again, it's in miles. By the way, for the sake of argument, if this number is greater than any of those is wrong, it must be less than both because the H is smallest among, if you compare this one, and this. However, I really wouldn't use that one. Instead, I'm going to go with sine of 75 is the opposite D over the hypotenuse 3.21. Class, I would use this. Sine of 75 degrees is the opposite D over the hypotenuse 3.21, which makes D the product of these two, which is exactly the same. By the way, sine 90, as you know. I wouldn't use that. The only reason I did it, I just wanted to make sure, okay, this is the section of law of sine, so I wanted to use that, but no need to do so.